Alright, first problem we're going to look at for this Unit 4 review is a mixture problem. These are the ones that kind of give you guys the most guff. One solution 60% sugar, one's 25. You need 180 pounds at 40%. How much of each? My suggestion to you is make your two equations. I would use matrices to solve it after that. You could use substitution or elimination, but I would use matrices. Go ahead and give it a shot. Two equations always. First equation is going to be x plus y equals 180 pounds. You always have a total equation and a percent equation. Okay. The percent equation, if I call this one my x and this one my y, right? It doesn't really matter in the grand scheme, but we're going to do 0.6x plus 0.25y, my percents, equals my percent times my total. Okay. Now from here, we could use elimination. We could use substitution. We could do a lot of things. I could do a lot of things if I had some money. But what I'm going to do is I'm going to take, I almost always, when I see a system of equations, I'm going to turn that into a matrix. So that's a 1, and a 180. 0.6, 0.25. Oh no, what's 4 times 180? Hold on, I got a calculator. Wait, did I just do 4 times 180? Give me crickets. 72. And a 72, because that's 72. Now, do you guys remember how to solve that beast on a calculator? If not, now's a good time to learn. Have your calculators at the ready. All right. Second matrix. Edit. How big is this matrix? 2 by 3. All right, and then plug it in. Sorry, I have to stay zoomed in on this beast or y'all can't see it. Hope I hit record. Ta-da! Now, what do I use to get these to be solved? What's the best way to do it? RREF, reduced row echelon form, as the cool kids call it. Oops. That's in your math. It's right by B. Names enters it. I got, oh no. So then you go second matrix. When you click on names, it enters it into the equation. So if you hit enter on names, it gives you the matrix. Sorry if that's a lot of scrolling. Because that was my original matrix. They reduced it. Sigma. So this tells me 77.14, right? And y was, let's see, I have an answer here. I'll just see if it connects. 102.86. So I had 77.14 of pounds of 60%. And 102.86 pounds of 40%. No, 25. That's why I label up here, because I'm not good at things. If you guys want more examples of these problems, we did do this in chapter 1 as well. So you can grab those questions from your notes or from that study guide and try to do it with the matrices. But like I said, I'm not gonna lie, from here on out, I use matrices. After I learned how to use matrices for systems, I never didn't do systems without matrices in any math class after that. Alright? Next request I had was a problem like number 19 from the study guide. Given, I don't know why that's there, I don't know why that's there, I don't know why that's there. The great almighty AI gods are adding bonus to things. Find the center. Find the center. There's Joel Embiid. Ha. Get it? Center. All right. For this ellipse, what's the center of this ellipse? Negative 6, 2. It's the opposite of what's by x, opposite of what's by y. What's the center of this hyperbola? Negative 3, 1. Oh, wait. Oh, yeah. Oopsie doodles. 1, negative 3. Why do we have to be careful with hyperbolas? Yeah, the x goes first in your points, but not always in your equation. And then what's the center of the circle? 2, negative 4. Opposite, opposite. So what if we have to solve exponentials like this? What if I have e to the 0.5x equals 150? And then I'm going to give you two problems for it. And what if I tell you that 4 to the x equals 91? Two exponentials for you to solve. Give it a shot. Give it the little college. Purple. What do I do to get rid of an e? Well, natural log both sides, right? So when you natural log an e, that goes away and your exponent comes down. But now this stays natural log of 150 because that's just some number. And now it's good old-fashioned algebra. Once you get rid of the exponential part, we're just going to divide both sides by 0.5. And then I plug that in my calculator. And my calculator says user error. No. 10.02. Ta-da! Good. Natural log. Anytime I see an exponent, I'm just going to natural log to get rid of that exponent. I even do that for b. So now, natural log of e is a cancel thing, right? That's a rule. That equals x. These are inverses of each other. Natural log is non-inverse of 4. So now when I natural log both sides of this, what I do is use my exponent rule to move the x out in front. Okay? So again, I'm getting rid of that x. Not getting rid of it, I'm moving it down. I can't solve for it once up in the air like that. And now I divide by natural log of 4. Now remember, if you use decimals for this, how many decimal points do you got to use?
6.
6, if you're using it in your work, right? 6 or 7. I'm just going to leave that whole thing in my calculator when I plug it in, because I make too many rounding errors, because I'm such a well-rounded person. I got 3.25. All the system equations. Again, is there a way to do this with elimination, substitution, all that good jazz? Yeah. Would I ever recommend that in my adult life? No. What should you do with this piece? Make it into a matrix. What's our first step on this? Make it into a matrix. That's not too bad, right? Be careful. I'm pretty sure on the test that was pretty nice, but always watch your variables. Make sure that they're in the same order. If you ever take higher up math or like linear algebra, they will try to get you by flipping those around. There you go. Once, did I write a y there for real? That's wild. No, it's a -3. Alright, once I have it into a matrix, I grab my calculator. I plug in the matrix. I quit. Alright, which button is it? 1. Augment, identity.
U.
Reduce row echelon form, please and thank you. And then I just hit enter on that matrix. Jiminy Crickets, that's gross answers. Hold on. Oh, that is U. So how do I know which one's my x and my whatever? It goes in order, right? Whatever you put first. So x is equal to 2.38. Y is equal to negative 0.73. Z is equal to negative 0.13, right?
Yeah. Wait, can you go back to your code?
Yeah. Find all the zeros using the rational zero theorem. Alright. Let's talk about this beast. Rational zero theorem says, right, our Q over P, our P over Q. You take your factors of your first and your last, you divide them, right? Oh, Jiminy Crickets. So, what are my factors of 30?
1 and 30 is
Negative 1 and 1. Negative 2 and 2. Negative 3 and 3. 4 is no 5, 5, negative 5 and 5. Negative 6 and 6. Negative 10 and 10. Ooh, this one's rough. There's a lot of factors. Negative 15 and 15. Negative 30 and 30. Now, are you going to have to plug all those into it? Yep. Now, hold on. I got to teach this to you the right way, just in case some of you move on to math. Just a reminder, then you'd also have to find your factors of 1, which are negative 1 and 1, and then divide these by it. But once you get a big number in front of your x to the third, you're not going to ever use rational zero theorem. That's why I'm not going to teach it. It's not an effective method. So then what do I do with these numbers? Plug them in. F of negative 1 is not 0. Now remember, on your calculator, to make your life a lot easier, don't forget that you have, oh, Jiminy Crickets, I haven't done any math on this yet, really. Just remember, if you have like an equation, to hit up arrow or hit second enter, and then just re-enter in your x's, right? But yeah, you're just plugging them in.
This was sent to last week.
This is the last week of college algebra.
School.
F of 1 is
May 10th to 8.
not 0. F of negative 2 is
Yes.
0. So negative 2 is one of my zeros. F of 2 is not 0. What's f of negative 3? Not 0. Guys, guess what f of 3 is? 0. Guess what f of 5 is? 0. So, now again, this problem is extremely tedious, but the nice thing about it is you'll know when you get it right, because you plug in the numbers and you get 0.
How do we,
Last bonus problem is this one. Convert to standard form by completing the square. You do not need to round. I'm not going to give you a problem that you need to round on that, because that's goofy. What? Yeah, but use completing the square. Remember to get all your variables together. Give it. First things first, I'm going to get all my x's together. Remember, because you don't want to be behind them. And leave a space. I'm going to get all my y's together. And what do you want in between you and your x's? Space. And where's that negative 12 got to go? To the outside. Because I'm constant. And we need, no, I'm just kidding. That's fine. That's probably why, hold on. Alright. Divide by 2. And then square it. If you weren't here for the completing square lesson, it's just something you're going to do every time. You divide it by 2, square it. Divide it by 2, square it. Add it to both sides. It's not as bad as what it looks. You're just going to do the same thing over. That's negative 3, right? Divide by 2. Square it. Add it to both sides. Okay? That's it. One more step and I'm done. Is this something that's factorable now? Yeah. It's x plus 5 squared. How did I know that it was 5 so quick? It's where the divide by 2 was, right? Plus. So this one's going to be y minus 3 squared equals 27, 30, 36. The radius is 6. And there you go. Divide by 2 squared, your b term. Divide by 2 squared. Add to both sides. Okay?
Okay.